Hello everyone. So until now we have covered 1D matrix prefix sum techniques, and I suggest you to watch those things before coming to this 2D matrix because it is quite simpler if you have watched 1D and come to have 2D. Okay, so the same three things which we have learned for the 1D array: prefix sum from 0 to ith index. So here it will be prefix sum from 0 0 to row comma column. Range sum queries there from L index to R index. You have to do the sum of the nums. Okay, here also you have to do range sum from row 1 I column 1 j to from some row 2 I column to j. And the same scanline algorithm for range query updates in 1D array. And here also the scanline algorithm for 2D array. Okay, the same thing. So this is the 2D matrix which is given to you. And let's say if we go for first for the first topic, okay, where we have to find the range sum from 0 0 to row comma column. Okay, so let's say you have to find from 3 to 0, I mean from 0 0 to 2 2. You have to find the prefix sum, you have to calculate the prefix sum. Okay, I'll prefer for prefix sum in 2D matrix. You will always do one based indexing because that will be good. Otherwise you need to check the condition of I and j every time. So first let's just go to the formula which you need to apply while calculating the prefix sum, and then we will see on how we have to apply this formulas over here. Clear? Okay, fine. So prefix sum of I j is equal to prefix sum of I minus 1 j plus prefix sum of I j minus 1 plus nums of I minus 1 j minus 1 minus prefix sum of I minus 1 j minus 1. Now, if you will do zero based indexing, you will get to know that what you have to do, you have to check for I minus 1 j condition every time. So, you need to check while doing this that I minus 1 should be greater than 0. Then only you can do this greater than equal to 0. Then you can add this term. For adding this term also, you need to check that j minus 1 should be greater than equal to 0. For doing this both things, you have to check that I minus 1 j minus 1 and this thing I minus 1 j minus 1 again. This two also should be greater than equal to 0. Then only you can do this. Okay, so basically for first row and first column you need to do manually, and then rest of this you can do. But if we do one based indexing, in one based indexing what we will do, we'll add one extra row and one extra column with zero zeros. Okay, and then it's easy to do for the entire array which is left. Okay, so we'll have one based indexing for this nums array. Consider this as nums array and this as the prefix sum which we're going to calculate. Okay, this is 4 rows 5 columns, so we will have this 5 rows 1 2 3 4 5 and 6 columns 1 2 3 4 5 6 columns. Okay, so our first row will be 0 0 0 0 0 0, and our first column will also be 0. Okay, so our first row and first column is filled with 0 0. Now we will apply this formula. Okay, now you just see what you have to do when you are at this particular I comma jth index. Okay, when you are at this particular I comma jth index, what you have to do is you have to take this upper row and left column. Okay, and this initial value whatever is there in nums. Okay, so as this is one based indexing, here you have to take 3 as it. Okay, this is for zero based indexing, so you have to do I minus 1 j minus 1. So here it is 1 1, but actually it is 0 0 for your original 2D matrix because that is given on zero based. So you will take 3, you will take prefix sum of upper row, prefix sum of left column, and this will cover 2 times this particular box. Okay, what this upper arrow will cover, upper arrow will cover this much area, upper arrow will cover this much area. Okay, and what this arrow will cover, let's see what this arrow will cover, this arrow will cover this much area while doing the prefix sum. Okay, and whatever value is there, it's there 3 which you have already added on the original. So you can see this thing is covered twice, so you have to remove whatever is there on the uh, I minus 1, j minus 1 of the prefix sum. That is on the top left corner. Okay. Same thing for this. Same thing if I am at this particular index. Okay. And if I am at this particular index, I have to take this. I have to take this. Okay. What my upper arrow will cover, if I can see, what my upper arrow will cover this box. Sorry, this box. This the prefix sum until this six call this six rows, this six boxes, 1 2 3 4 5 6. And what my left will cover? My left will cover this six. Okay, this 6 1 2 3 4 5 6, and whatever is here I'll write. So you can see this four boxes, 1 2 3 4, this four boxes will be covered twice, so you have to delete that by this prefix sum of I minus 1 j minus 1. If you'll do that and you will fill the matrix, your matrix will be filled. Okay, let's just clear this out, everything messed up. Okay, I'm putting it this much only so that you can understand. Okay, so this way your matrix will be filled. Okay, and you will get the answer. So this is simple for prefix sum from 0 0 to I j row column. Okay, this is the formula which you have to just remember. One thing you have to remember is make this is the formula for one based indexing. Okay, let me just clearly mention it over here also. This is for one based indexing only, not zero based. Clear? Okay. Okay. So this is how we have created the, I've used the formula and filled this matrix. Okay. 1D prefix sum matrix from 0 0 to ij. Now let's move to another question over. Now we have to find the range sum from row 1 I column 1 j to row 2 I column 2 j. Okay. So let's take one thing. Let's say I want to find from, oh, sorry. Let's say I want to find from 6 this to this one. Okay. I need to find from first row, first column to 0, 1, 2, 3. Third row, third column. Third row, third column. This is what I need to find. Now I don't need to find from 0 0 to. Okay. So there are two things to remember. Okay. First thing, you will be given this row 1, column 1, and row 2, column 2 on basis of nums array, which is 0 based. And we have to calculate it from prefix sum pre-computed, which is 1 based. Now, why we have to calculate it from prefix sum? Let's say there are q such queries. Okay, this is actually queries. This is actually what? Queries. We have seen, right? This is actually queries. It's not just one case like 1 1 2 3 3. No, there are q such queries where you will be given row 1, column 1, row 2, column 2, where you have to find the sum from row 1, column 1 to row 2, column 2. Okay, so every time you can't go from 1 1 to 3 3. Okay, I've calculated. Now for another query, let's say 0 to this 7. Okay, I've calculated. This 5 to this 0. Okay, I've calculated. No, you cannot do this. If you will do this for every time, what will be your brute force time complexity? Your brute force time complexity will be to do this every q times. You have to traverse this full 2D matrix. So it will be n cross m cross q. So we have learned in 1D prefix sum that we can do this by pre-computing the prefix sum. We can first pre-compute the prefix sum for 0 0 to particular I comma j column and row, and then we can use this prefix sum to calculate any range queries or range sum queries whichever we have asked for all the queries. Okay, but this prefix sum is calculated on one based. So what we can do, just make it one based. Row 1 plus plus, column 1 plus plus, row 2 plus plus, column 2 plus plus. Make it one based. Okay, so now your row 1 will be actually 2, and column 1 will also be 2. Your row 2 will be 4 and your column 2 will also be 4, because it's from 1 1 to 3 3. So with one based it will be from 2 2 to 4 4. Okay, now let's go to the formula. This is the formula which you need to remember. Okay, so answer will be equal to prefix sum of row 2 col 2 minus prefix sum of row 1 minus 1 col 2 minus prefix sum of row 2 col 1 minus 1 row 2 col 1 minus 1 plus, sorry, plus prefix sum of row 1 minus 1 column 1 minus 1. This is the answer which you need to remember. Okay, now let's see the example of it. So this is for row 2 col 2. So actually this is row 2 col 2 is this 4 comma 4. So 4 comma 4 is 0 1 2 3 4 and 0 1 2 3 4 0 1 2 3 4. So this is 34. Okay, so this is row 2 col 2. This you have to take. So basically this 34 refers to what? Sum until 1 from 0 0 to 1. Okay, from 0 0 to 1. Okay, so I'll just mark this full, it will cover this full sum. Okay, just understand it clearly so that you cannot, if at all you forget the formula, you can use this thing. Okay, so this you have taken, this whole sum you have taken. Now what you have to do, you have to subtract this top row and this left column, which is above 6 this full row and left of 6 this full column. This two you need to subtract. How we'll do it is, so two things we subtracting. Prefix sum of row 1 minus 1 col 2. So row 1 minus 1 is 1 and col 2 is 4. So 1 row fourth column, 1 row fourth column is what? This thing. So 8 refers to what? 8 refers to what? This 4. 8 refers to sum until this 4. Okay, now let me just change it. So you will subtract the sum, this sum you will subtract. Okay, we have seen until this 4, row 1 minus 1 col 2. Now what we need to subtract, we also need to subtract row 2 and col 1 minus 1. So row 2 is 4 and col 1 minus 1 is 1. So fourth row first column. Okay, let's check fourth row. Fourth row first column is 17. Sorry, 9 9 9. Fourth row first column 0 1 2 3 4. Fourth row first column is 13. So 13 refers to here 4. Okay, so this 4, until this 4 we will subtract. Let me just change the color again, and this is it. Okay, until 13 we will subtract. Okay, so on my nums array, if I can see you, this is what we gonna subtract from here to here. This is gonna be subtract. Now see, this 3, this is subtracted by this blue subarray also and by this purple subarray also. So this part is subtracted twice. So we need to add it. Okay, if we subtract it twice, of course our answer will be low. We have to subtract it once only, either for blue array or for purple array, not for both. Okay, so we will add prefix sum of row 1 minus 1 column 1 minus 1. So row 1 minus 1 is 2, column 1, so row 1 minus 1 will be 1, column 1 minus 1 will be also 1. So here 1 1 is what? 1 1 is what? 3 3. Okay, so I can add this row 1 minus 1 column 1 minus 1 until here whatever is the sum, we will add it again one time because it was subtracted twice, we will add it again. So I hope you remember. You have to take until this 1. Okay, row 2 col 2. You have to subtract for row 1 minus 1 col 2. Row 2 column 1 minus 1. As this is subtracted twice, add it again, row 1 minus 1 column 1 minus 1. This is how your range query sum. Okay, you can remember the formula, but if at all you forget, if you have understand this and remember it, I'm damn sure you will remember it. And this is very important questions asked many times because this is the most optimized technique you can do on this. Okay, cool. Okay, so after following this approach, what will be your time complexity and space complexity for this optimized technique? It's nothing, but you just need to pre-compute it once, and then it's just order of one in one, or you have to just apply the formula. So time complexity is order of n cross m, and space complexity is also order of n cross m. Why? Because we have to pre-compute the prefix sum by making one another area of prefix sum. Clear? Now we will move on to the scanline algorithm for 2D matrix. Okay, mostly as I have said in 1D also, uh, zero matrix is given. So 2D matrix of size n cross n filled with 0, 0, 0s. Okay, you are given q queries of the form of x comma l comma r, or here it could be like, okay, x you have to add from row 1 column 1 to row 2 column 2. This could be your q queries form. Okay, this could be one query. So you have to add x now from row 1 column 1 to row 2 column 2 inclusive. Okay, and after applying q queries, what will be your final error that you need to return it? Mostly it will be zero matrix. If not zero matrix, consider that same size of n cross m whatever given, that okay, you have to change in nums, make one another matrix of size n cross m with 0, apply this all steps which I'll be mentioning you now on that 0, and then add both those matrix, add each row each column separately after by running two loops. I hope you get it, as we done on the 1D also. Okay, so let's just consider 2D matrix, and you will be given this x you have to add. Now to remember it easily, okay, now to remember it easily, for all queries what you can do now, no need of here, no need of zero based, one based. I mean, you don't need to calculate prefix sum for this, correct? You have to do, all you have to do is in the nums array only. So no need of adding this row 1 column 1 by plus 1 plus 1 plus 1 plus 1. Okay, but the same formula you can remember wherever is minus. Okay, this row 1 minus 1 column 2 col 2 has minus sign, so there you need to minus equal to x you need to do. Okay, and wherever there is plus sign, there you need to do plus equal to x. So I'll just tell you the formula. In 1D we are doing array of l plus equal to x and r plus 1 minus equal to x. Okay, here what you have to do, here you have to do array of row 1 column 1 plus equal to x, array of row 2 plus 1, row 2 plus 1, and column 2 plus 1 plus equal to x. So why? Because row 1 minus 1 and column 1 minus 1. Why? This is minus 1. Here you need to do plus 1 because this we have done for 1 based indexing. Now we have to do for 0 based indexing for whatever array. So here we have done plus 1 already. Okay, we have made row 1 actually plus 1. So if we not do plus 1, then it's just row 1 only. Correct? So we'll do array of row 1 column 1 plus equal to x. Same for here row 2 col 2. So here while doing made it plus 1 plus 1. So row 2 plus 1 col 2 plus 1 plus equal to x. And array of row 1 col 2 plus 1 minus equal to x, and array of row 2 plus 1 col 1 minus equal to x. So we are doing row 1 minus 1 col 2. So it's basically row 1 col 2 plus 1. I'm adding plus 1 everywhere. So row 1 col 2 plus 1 minus equal to x, and row 2 plus 1 col 1. Row 2 plus 1 col 1 minus equal to x. Wherever you have done plus sign, do plus equal to x. Wherever you have done minus sign, do minus equal to x. After doing this, apply prefix sum after performing all q queries. That's what we are doing on the 1D array also. Okay, so this is the formula you need to remember, and after that you need to apply the prefix sum after performing all q queries. We can quickly jump to the question on the lead code for this thing. Okay, there is one question of this thing also which I have explained you very clearly. I can put that in the description, you can do that by yourself. For scanline, I can quickly jump to the lead code question and we can solve it over there. Fine. Um, this is the question. Increment submatrices by 1. Okay, you are given a positive integer n indicating that we initially have n cross n zero indexed integer matrix filled with zeros. You're also given 2D integer array query. For each query I, row 1 I, column 1 I, row 2 I, column 2 I, you should do the following operation. Add 1 to every element in submatrix with top left corner as row 1 I, column 1 I, and bottom right corner as row 2 I, column 2 I. Okay, so here they have fixed the x as 1 only. For every query, you have to add 1 only, fixed. Not different x are given. That is, add 1 to matrix x comma y for all row 1 I until row 2i and for all columns from column 1i to column 2i, and you have to return the matrix after performing every query. Clear? Now we have to return the matrix after performing every query. So actually what we have to return after performing q queries, we'll do prefix sum and we need to return that prefix sum itself. So creating 1D or one based indexing prefix sum will be difficult because that will have an extra row of 0 0 and column of 0 0. And we can create another prefix, we can create another 2D matrix and remove that things. Okay, we'll do that only. That would be easy rather than going for zero based prefix sum. Okay, so uh, let's just quickly go to our queries part. Okay, for int I0 I less than queries dot size I plus plus. For int J0 J less than queries of I dot size J plus plus. Now I'll quickly take row 1 as queries of I0, row 2 as queries of, sorry, this is row 1 column 1. Okay, it's given in form of row 1 column 1. So this could be column 1 as queries of I comma 1 and row 2 I2 and call to I3. These are the 4 values given. Okay, now what we have to do? You have to change this. Okay, you're not given this matrix array. You have to create it. Okay, so let's just quickly create vector of int matrix of size n cross n with 0 based. Okay, now what we will do, as we have learned, this matrix of row 1 col 1 plus equal to 1 or plus plus. Okay, and matrix of row 2 plus 1 col 2 plus 1 plus plus. Matrix of row 1 col 2 plus 1 minus minus, and matrix of row 2 plus 1 col 1 minus minus. Okay, we have done this for all q queries. Okay, we are done. Now we have to do the prefix sum. So we will create one prefix sum also, but we will create for n plus 1 cross n plus 1. Okay, you can make for n cross n and you can apply that like, okay, I minus 1 greater than 0, then only I'll add this and all. Okay, you can add the extra conditions and reduce the space, but it's okay, it's not that much space. Okay, just adding one row and one column, it's okay, it's good. So we'll do the prefix sum for int I 1 to n and for j 1 to n. Okay, let me just shorten it by sum only. I'll do sum of ij is equal to sum of I minus 1j plus sum of ij minus 1 plus matrix of I minus 1 j minus 1 minus sum of I minus 1 j minus 1, because that has been added twice. So we are done with this. Now this could contain this will be containing one extra row of 0 0 on top and one extra column of 0 0 on the left. So we need to remove it. So we'll make one final vector of size n cross n only. Okay. And we will traverse this array. Our original will be from 1 to n, 1 to n only. And we will copy those values in our answer array. So answer of I minus 1, j minus 1, because this is 0 based. We have to feel 0 based from 1 base. So sum of ij. Clear? We will return this summary, return this answer array. Let's see. Okay. Uh-oh.
Okay, I think the mistake is here. We have already taken queries I0, I1, I2, and I3 as row 1 and all. We do not need to go in depth of J. No need of it, right? And also, we are doing this row 2 plus 1, call 2 plus 1. So it can be possible that this goes beyond n. If call 2 is already n minus 1, then this can go at n. So it's better to make this matrices of size n plus 1 on safer side. Okay, let's try now. Fine. Yeah, we are able to do it. Okay, so this is halfway to a prefix sum, we can say. We have completed 1D and 2D with all the important topics. Now comes subarray sum in prefix array. Subarray sum using maps, using prefix sum. Okay, you have to calculate or you have to do something on subarrays of the array. Okay, now we will cover that in the later half of this playlist. Stay tuned for it. Do hit like, share, and subscribe if you like it, if you learn really from it. And I'm always welcome for feedback. If you have anything, you can comment me down or you can connect me on the LinkedIn also. Okay, stay good, stay safe. Bye bye.